Okay guys, here we go. We're going to be talking about tangents today. So first thing is just a review of the vocab term. You should already have this in your notes from a couple weeks ago. A tangent is just a line that intersects a circle at exactly one point. That point's called the point of tangency. Okay, so if we look at this example over here, I would name the tangent, oh, let me grab a pen, sorry. I would name the tangent line AB, and remember that we use that notation over the top, and then that point of tangency is just point A. It's where the tangent meets the circle. So that's a quick vocab term. So the lines are going to hit the circle one time today. There's a few theorems that go with it. Okay, so the first theorem that it says is in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn to that point of tangency. So basically, when I look at this diagram, I can see that line L is my tangent. So this is my tangent right here. And they're saying that this line is tangent to the circle if and only if this radius, which is segment CT, is perpendicular. So what I can say is if CT is perpendicular to line L, then I can assume L is tangent. Okay, now one thing down here, it says the converse is also true. So if they give me information that L is a tangent, like they say that first, then I can assume that this radius right here has to be perpendicular to it. So it works both ways there. Okay, this next example problem says JL, segment JL is a radius to circle J. Determine whether segment KL is tangent to the circle. So this one they want us to determine. So what we want to think about is if KL was a tangent and it meets the radius, that last theorem said that they would have to be perpendicular. So what we're questioning is this a right angle right here? So what are we going to use to determine if I have a right triangle? Pythagorean theorem. Okay. One thing that's a little bit misleading about these diagrams is some students will say that this full segment KJ right here is 9, but that doesn't quite make sense. Because if that was the hypotenuse, we know the hypotenuse has to be the longest side of the triangle. So what's missing here is this segment right here is the radius, and I already know the radius measures 8 from J to L. So this whole side length right here, I want to use 17. Okay, so I'm testing Pythagorean theorem. I'm going to say 8 squared plus 15 squared, does it equal 17 squared? That's our question. 8 squared will give us 64, 15 squared will give us 225, and 17 squared, I believe, is 289. Yep, so 289. So here I say 289 is equal to 289. So I would say yes, because KL is perpendicular to JL. That would be my reasoning, because it does ask me to justify my answer. Okay, so if it comes out equal, it is a right triangle. What would happen if these two values here were not equal? We would say, no, it doesn't satisfy the Pythagorean theorem. Okay, this one right here says JH is tangent to circle G at J. So we're assuming this line right here is a tangent. Find the value of X. Okay, so we're assuming that's tangent. We're going to say X squared plus 12 squared is equal to X plus 8 quantity squared. Here I get X squared plus 144 is equal to, remember this means I'm going to take X plus 8 times X plus 8. Some students want to distribute that exponent, but that's not the correct rule with exponents. So here I get X squared plus 144 is equal to X squared plus 8x when I bring this x through. Now I'm going to bring the 8 through, and I would also get 8x plus 64. Next step, x squared plus 144 is equal to x squared plus 16x plus 64. Okay, when I subtract the x squareds, they are going to cancel out, which works out really nice for this problem. Next thing I'm going to do is subtract the 64, and when I subtract 64, I'm going to end up with 80 equal to 16x, and when I divide by 16, I'm going to find that my x value is 5. Whoop, whoop.
Roxy?
Yeah.
Hungry?
Okay, next theorem says if two segments from the same exterior point are tangent to a circle, then they are congruent, is what it's going to say. Okay, so if I wanted to interpret that with this diagram off to the left, what I would say is if AB and BC are tangent to circle O, then we can assume that AB, segment AB, is congruent to segment BC. Okay, so yeah, basically that's just saying that those two segments are going to be congruent. Okay, looking at this diagram right here, it says DG and DH are tangent to circle T. Find X and Y. Okay, so if I'm looking at that diagram, DG and DH are tangent to that top circle. Okay, I also know that it looks like they're touching circle S at one point as well. So I think we can assume that 10 is going to be congruent to Y. Once I know my Y value, I can plug it in up here and say that this segment is 10 minus 5. My goodness, 10 minus 5, which is going to be 5 for the length of this segment. And if this segment is 5, then over here should be as well. So I'm just going to say x plus 4 is equal to 5, and we're going to find our x value to be 1. All right, last piece for this one says that term circumscribed once again. So a circumscribed polygon, it's talking about the polygon surrounding the circle, okay? And what we know about that is that each side of that polygon has to be tangent to the circle. So each side is going to touch the tangent at one point, okay? So we're really going to use that idea from the last slide to find the measures of these segments, okay? So like this one here, this first one, I have a square that's circumscribed about the circle, and I see the radius of the square is 8, which means if I filled in a radius over here, I would get 8, meaning this full segment right here is going to be 16, okay? On the next one, I assume that these are two tangents, so if this segment is 4, then the other segment is 4, and since it's a regular figure, I know all the side lengths are going to be the same. Okay, really, each side length is going to measure 8 and 8 and so on, but we're really going to say x is equal to 4 here. The last one, remember we said two tangents from the same exterior point are congruent, so I could say this segment is 2. Okay, this segment down here, what would it measure? It would have to be 4. This segment over here would have to measure 6, so if I wanted to find the length of x, I would just take 6 plus 4 and say x is equal to 10. Okay. These are just practice problems using those theorems from earlier. We're going to kind of skip the practice problems. Just a good one to review, this one down here. Once again, remember we can say this is 21. We would use this as 29. So just a good reminder, these would be on the right angle. Sorry, I'm touching the screen. Okay, last problem for today, and it says circle B has a center at 3, 6, and RO is tangent to circle B at 5, 2. Find the slope of RO. Now, one thing that I could do is I could kind of sketch it to get an idea of what they're saying. So 3, 6. This is the center of my circle. And then it says that I have RO as a tangent, and it touches circle B at 0.52. Okay, so this line, we don't actually know which direction it travels, but it's brushing up against this circle at this point. Okay, finding the slope of RO. So this line down here is going to be RO, and what we would do here is we would draw in this radius. Now earlier we said what? The radius has to be perpendicular to a tangent. So what I could do here is find the slope from point B to that tangent. So really finding the slope of the radius. Remember your slope formula. It's the rise over the run. We've talked about the yummies on the picnic table. Okay. From there, what would be our rise if I'm going from point B to that point O? Okay, comparing the y coordinates, it would be like
6 minus 2 over, then my x coordinates would be 3 minus 5. Okay, 6 minus 2 would give me 4. 3 minus 5 gives me a negative 2, so my slope here is negative 2. Now remember, this is the slope of the radius. But what they're asking for is the slope of this line RO. We said it needs to be perpendicular to the radius, so the slope should be the opposite reciprocal of negative 2, which is actually going to be a positive 1/2. Okay. Assignment for today is going to be tangents and segments and circles worksheet, and that will be posted on Google Classroom. It's also posted on the website under the worksheets tab, and we are in Unit 8 if you want to look there. Once again, just a reminder to check your work when you're finished with the answer key. If you have any questions, please email me. Have an awesome, awesome day. Thanks for tuning in. Bye, guys.